We have two special types of right triangles that we're going to be looking at in this chapter on special right triangles and using right triangles. One of them is the 45-45-90 right triangle, called that because of its angles. You get a 45-45-90 by drawing a diagonal of a square, so it's a pretty common figure. Like every right triangle, it has two legs. I'm going to call this L for leg, and I'm going to call this L for leg. And I can use the same letter on both of them because the two legs are always equal. If you remember the isosceles triangle theorem, it says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So the two legs of a 45-45-90 are always congruent. In fact, that's going to be one of our rules for 45-45-90 triangles. Rule number one, which is pretty easy to deal with, the legs are congruent. Now, we can also work that one backwards. If we have the legs marked congruent and the angles aren't marked, we have a right to know that those are 45-degree angles. Okay, now we want to find the relationship between the legs and this guy, the hypotenuse. So, to develop that relationship, we're going to use the Pythagorean theorem. It would say that the leg squared plus the leg squared equals the hypotenuse squared. So that would be L squared plus L squared equals H squared. Well, L squared plus L squared would be 2L squared equals H squared. So I'm going to switch sides with the H on the left and go ahead and take the square roots of both sides. The square root of H squared equals the square root of 2L squared. Okay, well, H and L are positive, so I can just take the positive answer for their roots. So H will be the square root, and the square root of L squared will be L. The root 2 will be left underneath here. So what I'm getting is L times the square root of 2. Well, that gives us our rule then for 45-45-90s and the relationship between the hypotenuse and the legs. And that is that the hypotenuse is one of the legs, and since they're the same it doesn't matter, multiplied by the square root of 2. If you forget the rule, you can always go back and recreate it by the Pythagorean theorem. Okay, so let's give two quick examples of using this rule. Let's say that the leg, L, is equal to 6, and we're supposed to find the hypotenuse. Well, this is going to be really quick and easy because the rule says hypotenuse equals leg root 2. So hypotenuse, that's H, equals leg, that's L, which is 6, root 2. Game's over. Since we had this nice rule to use, that's all we have to do to find the length of the hypotenuse. Okay, let's give you a second example. I'm going to erase this one because I may need a little more room. So if you need to copy it down, pause me. In this example, I'm going to give you the hypotenuse. The hypotenuse, H, will be 17. And as you might suspect, we're going to find L. Well, the rule doesn't change because I'm trying to find something else. The rule is still hypotenuse equals leg times root 2. So under hypotenuse, I'm going to write this 17. It equals the leg, which is my L, root 2. Okay, when you're trying to solve an equation for a variable, then the variable is being multiplied by something. You will need to divide by that thing on both sides. So dividing both sides by the square root of 2 causes the square root of 2's to cancel. So L will be 17 over the square root of 2. Now, if you're not required to simplify your answer, you're done. If you are required to simplify your answer, you simply need to multiply top and bottom of this by the square root of 2. So if I do that, times square root 2 over square root 2, up in the numerator we get 17 times the square root of 2. Can't combine them together any better than that. And root 2 times root 2 is 2. And so there's your answer in simplest form. And that's about as hard as it gets for 45, 45, 90 triangles. You might say, well, which L did you find? The answer is I found both of them because they're the same.